and then Q goes closer and closer to P, and here is how we're going. Look here at the plot. What happens? Now, would you agree that the blue line becomes closer and closer to the tangent line? Huh? Makes sense? The blue line. Blue line at the moment is far away from the tangent line, but as we continue to put x closer and closer to A, so here is the definition of the slope of the tangent line. So first we have a point on the plot of the function A and the y coordinate f of A. Now here we said that we're going to use the limits, and here on the top delta f over delta x with fixed one side point, and x goes towards A. So the derivative is based on limits. Okay, so this slope is, we're going to define M to be the slope of the tangent line at that point. Okay. And the tangent line, of course, will have that equation. Y minus y1 equals M inside the bracket x minus x1. So now you can check, is this point lying on that line? For sure, right? Because here y is f of A and here x is A, so it becomes 0 equals 0. We will talk about that a little bit later. For now, everything is going to be very simple. Now, guys, what did we find? We found the tangent line, the equation of the tangent line. What was that? Let's write it here. Let's write it here. Okay, so we said the point P from the plot is 1, 1. So the tangent line has to be y minus 1 comes here equals M x minus 1. This one comes here. And then we found that M, it should be something like 2, very close to 2. So after that we concluded that the tangent line y minus 1 equals 2 multiplied x minus 1. But now we want to find the same equation analytically. Analytically, not with a table and we trace some value. We want now analytically. When we use the word analytically, what does it mean? Formulas. Formulas, not just graphics and not just intuition. So now we're going to use this definition about the limit, because limits is an analytical technique. We know how to deal with limits. Okay, so this is the limit we have to compute. The function is x squared, so we replace. We get this. What kind of a limit is that? What kind of a limit is that? Can we solve that limit with direct substitution? Let's try. What does direct substitution do? We substitute x with 1 and we get what?
1, and then we get 0 over 0.
We get 0 over 0. So direct substitution does not work at the beginning. But now we can do factoring in order to simplify. And when we factor, we get this expression now. Now we can cancel these two factors, the top and the bottom, here x minus 1, for one reason. X goes closer to 1, but it's never 1. Because it's never 1, we can cancel. And now direct substitution works. 1 plus 1 equals 2. Okay. So now, here is the slope. We found it analytically. We found it with our knowledge of limits. Any questions, guys? If you can teach somebody at home about derivatives and about tangent line, it would be great. All right. Okay, so from here to come here, it's not complicated. You open the brackets, minus 2, and then plus 1, minus 1. It's simple. Okay, so now, in mathematics, very often there are more than one equivalent definitions. So now we're going to come to the second definition. The second definition, instead of x minus a, it uses h. So what we do, we give a new name to x minus a. Here is our x, and x minus a, this distance from here to here, we are going to call it h. Now, x becomes a plus h. So here instead of x, we put a plus h. Here is the same. And at the bottom is x plus a minus x plus h minus x. We get only h. Now this formula and the formula from the previous slide, they are absolutely equivalent. 100%. Okay, so now again, this is the same like before, and we come that the slope of the tangent line is the limit of this expression when h goes towards 0. It's absolutely equivalent. Now, the two formulas is good if you can learn them by heart. First, they can be derived one from another, and they're not so difficult. On the top is delta x, on the bottom is delta x, and we are taking limit when delta x goes towards 0. Okay, so now let's have some fun. We have this function 3 over x. Let's see here x3. So x is 3. 1, 2, 3. How much is y? 3 over 3, y is 1. So the point 3, 1 is on the plot of that function. Now, what do we want? We want to build the tangent line. Where is the tangent line? Here. This is the tangent line. So, first we start with the equation. I will write the most general equation, which you should try to remember. Y minus y1 equals m x minus x1, or here instead of 1 you can put whatever you want. Now let's apply this equation for this point first. So what should I write? What should I write? Can you come and write the equation of the tangent line? Guys, I gave you a reading assignment. What was the reading assignment? What was the reading assignment?
To read the slide.
To read the slide a little bit, right? And the equation of a line, it comes from high school. So what do I have to put? I have to replace y1 and I have to replace x1. And I have to replace m, but at the moment, don't worry about that. So y minus, how much is the y coordinate? 1 minus 1 equals, we put here m, x minus. How much is the x coordinate? 3. Alright, so now the only problem is m. The only problem is m. You see, if I tell you that everybody knows everything, but the problem is to know exactly where to look. And the place to look is just 3 and 1. 3 and 1, it's so easy after that. So now how much is m, guys? M. M, we're going to find it by using limits. So, m equals a limit, if the limit exists, of course. Now h, it goes towards 0. I'm starting from here. Now, we have to remember the previous slide. Who remembers the previous slides? Do you remember? Delta f over delta x. So look, I'm writing in a particular order. LIM, can you remember limit? Can you remember h goes towards 0? That's very easy, right? And then I put the line on the same level like the middle of m, and immediately I put h at the bottom. H is always at the bottom. So now the only problem is on the top. Minus, here is f of a. How much is f of a? Here is 1, right? Is 1. 1 comes from here. And now, here I have to put the function at a point 3, here x is 3, plus h. So what is the function? 3 over x. So I'm going to put here 3 over x. But now I have to replace x with... Guys, let's put the most general definition. Let's put the most general definition of the limit. So m is limit. M is limit. I'm going to put the two definitions. X goes towards 0, here here h, and here f, f of x plus h minus f of x. The point, let's put the point is x, f of x. We want to build the tangent line exactly at that point. And here, what do I have to put here? Now here the notation is a little bit different, so maybe we can abandon that at the moment. There are situations in which the first definition is more convenient to use. And there are situations in which the second definition is more convenient. At the moment everything is simple, but let's use the second, for example. So, here, let's put how much is x, guys? Here is how much? X is 3. And f of x is 3 over x. So here is 1. Now we need to put here fx plus h. So let's put here f of 3 plus h minus f of 3. I'm going from a little bit more complicated to less complicated, but slowly, step by step. Our function is this one. Now we have to put concrete function. I'm going to put it here on the top. On the top. So how much is f of plus 3 plus h. I'm going to take the function which is 3 over. And here is 3 plus h minus f of 3. But I already know how much is f of 3, 1. So guys, let's put here equal and let's work it out here. LIM, h goes towards 0, here is h. Now what do we have here? Some concrete stuff. 3 plus h minus 1. Let's try direct substitution. What do we get from direct substitution? H goes towards 0, so replace h with 0. What do we get? Huh? Three over 3 plus 0 is 1 minus 1, and here, so we get 0 over 0, right? We cannot use direct substitution. So now, what should we do? Let's try to work it out. 3 plus h. So instead of minus 1, we can write 3 plus h, 3 plus h. Now what do we get next? Huh? What do we get? LIM. Now here, 3 plus h, and on the top, 3 minus 3 minus h. Right. So now what do we notice, guys? We can cancel h and h, right? And what do we get? LIM. Here h goes towards 0. And we get h, 3 plus h, minus h. So we can cancel h. Why? Because h is not 0. H is only close to 0. And we get LIM minus 1, 3 plus h. H goes towards 0. What do you think now? Can we use direct substitution? Huh? Yes. So let's substitute. And what do we get? Minus 1 over 3. We are using our techniques from limits. We're using our techniques from limits. So now we have to go back. What was the main problem that we were solving? What was the main problem we were solving? Find the equation of the tangent line. So we want to find the analytical equation of this tangent line. We already have something. Y minus 1 equals mx minus 3. So now I just have to delete here m and put what? Minus 1 over 3. Now we can simplify this. Put on your notes a simpler form of this equation. It has to be y equals ax plus b. Any questions? Guys? Any questions? By the way, here in the slides, it's a little bit better done. You see here, we should have used brackets. Brackets are nice tool. They help us to find the right result and to be clear. So here the brackets are better. I didn't use the brackets and I like here that they have used the brackets. It's better with the brackets. Any questions, guys? Now what did you get? Miss Chin, what did you get? How much is A and B? Okay. This one, huh? The same. Guys, did you get the same here? Now, you can arguably say that this here is a simpler form of this. This and this, they are the same. They give us the same line. But this here is more beautiful. More sexy. Okay. Now, do you like to exercise, guys, or not?
Yes.
Okay, then, oh yes, but I'm talking about algebra exercise. Alright, so now it's 4:30. Huh? I think I have a problem. My daughter has temperature, sorry. But no, let's, here, let's do it as a competition. The sooner we finish this, building the equation of the tangent line with this parabola, the moment we finish everything clearly, put first in your notebook, and then somebody to put it on the board, and then we're done. And now may I ask you, why do you need 1, 2, 3 computers? No. Just one. But you can close it, man. Okay, no problem. No problem. So we're doing something several times already. We did it with the function x squared, we did it with the function 3 over x, and now the function is a little bit more complicated. The first thing is, let's check that the point 2, 9 lies on this plot. So what do we have to do? What do we have to do? So we want to know 2, 9. Does it belong to this plot? Y equals x squared plus 2x plus 1. Can you come and check? Yeah. You just have to substitute 2. Instead of x, you substitute 2. Instead of y, you substitute 9, and you check if you get, yes, 2 squared plus 2 multiplied by 2 plus 1. But, guys, you see here, now here it's clear, but here you have to put the question mark. The question mark means that you are checking if the left-hand side equals the right-hand side. Otherwise, if you just put equal sign, what does this mean? Yeah? What do you get? Put the question mark. Is it equal?
No one good.
9. Okay, now it's equal. Okay, thank you. Yeah, you can do stuff, man. How about the book? they return it? Do they borrow it? Huh? Yes. But guys, this guy has a book about the history of mathematics. You can borrow from him one night, you just go through the history, and after that, who knows, one day you might become a millionaire because you read that book. You read that book. Okay, so now, what do we need, guys? We need the equation of this tangent line, right? We need the equation. Who can come and put the equation, but m is m. We don't know m yet, right? So we just put the equation. For the slope, we use m. Come, come. Huh? Yeah, I'm listening. I'm listening. I'm listening. So guys, I'm going to write something maybe now for the 10th time. Please watch carefully. Y minus y1 equals m x minus x1. And this is equation of the line going through a point P equals x1, y1. But now we want to write for this point. Who can come and write it? Huh? Huh? Okay, go write it. Write the equation. Quick, quick. Y. Okay, we start correct. Y minus y1. What is y1? X. Very easy, exactly. So now m equals to how much? What should we use? Of course, limits. We know that m is a limit of something. Limit, what should we use? Let's use h. H goes towards 0. And I put here h. Who can come and put what is on the top? Can you come and put it what is on the top? In the most general form. Come. Come quickly. Okay, yes, that's, you know guys, you can remember something like this. Limit delta f over delta x. H is equals x plus h minus, x plus h minus x. You know here, instead of a, we use x in the second definition, but it doesn't matter. The most important problem is here. It's not plus, because delta m, it's minus, yes. Here it's minus. Okay. Now who can come and put here is h goes towards 0, and put now the concrete function, this one, and the point is 2, right? So we have to put f x plus h minus f of x. X is how much? Is 2. X is how much? Is 2. Who wants to come? Huh? Can you come?